Good morning. This is the notes for 1.5. So today's lesson is all about angles. So we talked about segments last week. So an angle is formed when you have two rays that make an endpoint. Okay, that common endpoint is called a vertex. So similar to when we were talking about polygons last week. Each time you have a segment or a ray meet, it's a vertex. The rays are the sides of the angle. You name an angle using 3 letters or 3 points. So in this case, and you always want your vertex in the middle. So using the angle symbol rather than writing it out. So we have a symbol for an angle, very similar to the less than sign, but kind of flat on the bottom. So we could name this angle ABC, or we could name it CBA. Notice the vertex is in the middle of both of these. If it is an angle that's all by itself, you can also just use the vertex to name it. Sometimes what they will also do is put a small number in here, and you can name it by that. When you're referring to the measure of the angle, which we'll talk a little bit more about, instead of writing out the measure of angle, you can use a lowercase m. So the measure of angle ABC is 60 degrees. Okay. When you measure an angle, you use a protractor. So typically on a protractor, you have a straight edge at the bottom of it, okay, that you can actually use. But to actually start measuring, you need to line up your vertex at this little cross or T. If it starts on the lower left side, if one of your rays is on there, you will use the inner set of numbers. If we were starting on the left side, you would use the outer set of numbers. Just be consistent in when you're doing that. Classifying angles, there's different ways to classify an angle. If an angle, and they're based on the angle measure. So if the angle measure is greater than 0 degrees but less than 90, it's acute. If it's exactly 90, it's right. If it's greater than 90 but less than 180, it's obtuse. And if it's a straight angle, it measures exactly 180. So I'm going to do an example of naming an angle. So I want you to be able to recognize the vertexes at K. This angle is made up of ray KL and KJ. There are 3 different ways to name this particular angle. Since it's by itself, I can name it angle K. I can name it angle JKL and angle LKJ. Notice the vertex is always in the center when you're naming it. And although I don't have a protractor, I can probably estimate that here would be 90 degrees. So this would probably be an obtuse angle. Okay. One other thing that you will be able to do is use a protractor to find the different angles. So if it starts at the bottom, those are fairly easy. So if I wanted to find the measure of angle AOB, since this is at 0, I really just need to look at ray OB and find out, okay, if I'm starting here at 0, this is halfway between 30 and 40. So if I go to the small tick marks out here, that would be 35 degrees, which would make it an acute angle. If I did one that doesn't start on the end, what you're going to do, like angle COE, you're going to have to see where this is. And on this case, since we're not starting at the far left bottom on either one of these, you can either use the inner numbers or the outer numbers. It doesn't really matter, just as long as you're consistent. So this time I'll use the inner numbers. So if this is at 65 degrees, and if ray OE is at 145 degrees, I need to find the difference of those to find out that this would be 80 degrees, which also makes this an acute angle. If I wanted to find one like maybe, let me find a better one, like maybe BOE. This time I'll use the outer numbers. So on this one, this would be at 145 degrees. OE, if I use the outer number this time, would be 35 degrees. So I could still subtract those to find the difference. So that would be 110 degrees, making this an obtuse angle. Going a little more in depth on naming different angles. So in this case, I would not be able to use the vertex of this because there's 3 different angles here. So I'm going to mark these so we can see each one. So one of our angles would be focusing on just this angle right here. So I can name this angle EFG or GFE. It doesn't matter which one. It is the same angle. The second angle in this picture, or one of the other angles, is this angle down here. So I can name this angle GFH or HFG. And then besides the 2 small angles, if we do the whole angle here, I can either name it EFH or HFE, and those would be the 3 angles in the picture. When I post the notes online, I'll have all of them completed. If you need more examples, you can look at the notes. The second thing is the angle addition postulate. So if you remember last week, we did the segment addition postulate. So if I have a segment and I put another point on there, I know that segment AB plus the length of segment BC equals the length of the whole segment. There's one very similar to that for the angle addition postulate that basically just says that the 2 smaller angles, so if I split an angle into 2 different parts, that those 2 angles add up to the whole thing. So in this case, the measure of angle ABD plus the measure of angle DBC has to equal the measure of angle ABC. And right below this, I just did a different picture of one that looks more like the angle that was cut in half. So I can still say the measure of RSP plus the measure of PST has to equal the measure of angle RST. And then they're going to have you apply this. Some problems will be really simple. Here again, just like I did with the segment addition postulate, I'm going to do the angle addition postulate. So the angle of JKM plus the measure of angle MKL has to equal the measure of angle JKL, because that is our angle addition postulate. So if I substitute in what I know, I can then use simplify to find the measure of the entire angle, which in this case would be 116 degrees is the measure of angle JKL. Sometimes they'll give you one of the smaller angles that they broke it into, and they'll give you the entire angle. So in this case, they told us the measure of our angle RSU is 91 degrees. In the picture, we can see that the measure of UST is 69. So they want us to find the measure of RST. So the measure of RST plus the measure of TSU has to equal the measure of RSU. So this is the one we don't know, plus 69. So we're substituting in our values. So if we subtract 69 degrees, we know the measure of angle RST is 22 degrees. Sorry, I set an alarm for something else. And then they're going to add just a little more algebra into this. So this one is telling us the angle UWX is a straight angle. So remember, by definition, a straight angle is 180 degrees. So we know by the angle addition postulate that the measure of angle UWV plus the measure of angle VWX is equal to the measure of UWX. So we're going to substitute in what we know. So we know this is X plus 20 degrees. This is X degrees. This is 180 degrees. So if we combine like terms, 2x plus 20 has to equal 180. So if I subtract 20, I know 2x equals 160. So if I divide by 2, x equals 80. One of the things that I noticed on the last quiz was people would stop right here, but we didn't actually answer the question. So we need to go back and find the measure of UWV. So if I substitute in 80, I know this is 100 degrees. And the measure of angle XWB would be equal to 80 degrees. A similar example for this would be if you have a right angle. So they want you to recognize the symbol for a right angle. So same thing here. They want us to find CAD and the measure of BAD. So we know that the measure of those two angles added together has to equal the measure of the entire angle, EAC. So if we substitute in what we know, and we know that the whole angle is 90 degrees. So if we simplify this expression, this is just preparing you for some proofs next chapter. So 6x plus 72 equals 90. So if we subtract 72, we get 6x equals 18. So if we divide by 6, we find out x equals 3. And then we can go back and find the measure of angle CAD. So 3 plus 15 tells us that is 18 degrees. And the measure of BAD is 5 times 3 plus 57 when we substitute in. So 15 plus 57 tells us the measure of that is 72 degrees. And we can always check because those two really do add up to 90. Okay, the last thing is just taking this a little bit further. So same thing, if we know the length of two segments are the same, then we know those segments are congruent. So same thing with angles. If we know the measure of two angles, so in this case, the measure of angle A equals the measure of angle B, then we know angle A is congruent to angle B. So we know their shapes are exactly the same. Same thing with segments we can do with angles. If we have a midpoint or a bisector that makes those two segments the same. So if we have a ray that divides an angle into two congruent angles, then we know those two angles are the same. So in this diagram, ray BD is the angle bisector. So therefore, we know that angle ABD is congruent to angle CBD, which also means we know the measure of those two angles is equal. And then they're going to have you apply this. So some of them could be really simple. So if ray EG bisects angle DEF, find the measure of DEG and GEF. Well, if the whole thing is 92, if we divide that by 2, we know that the measure of each of these angles is 46 degrees. Okay. And even though I didn't put it on here, it would be if I covered this up and I said this is still the angle bisector, but I told you one of these is 25, then we know the other one would be 25 and the whole thing would be 50. And they can just take it a step further. So same thing here, if ray QR bisects angle PQS, they want us to find the measure of PQR and of PQS. So if this bisects, we know that the measure of PQR is equal to the measure of RQS, because if it bisects, the two are equal by definition. So if we know this is 4x plus 10 degrees, and this is negative 3x plus 130 degrees, I can use my addition property of equality to move my x's to one side. I can use it again to move my constants to the right side. So I can figure out by division property of equality that x is 20. And then I can go back and I can find the measure of the two angles that they're asking for. So the measure of PQR, so 4 times 20 minus 10. So 80 minus 10 tells me that this is 70 degrees. And if it's segment, we should just be able to multiply it by 2, but let's go ahead and find the measure of SQR. So negative 3 times 20 plus 130 is negative 60. So we also found this one is 70 degrees. which makes the measure of PQS 140 degrees. So I will post the notes on there. I think they already are, but this video should go along with it.